Good morning, students. In this unit, I am going to teach you about friction, one of the topic in engineering mechanics. Let us understand what is meant by friction. Friction is a retarding force that resists motion. Retarding force that resists motion. That means you consider this image. Here we have two bodies. One body over which another body is placed. So this magnification shows that the contact between the two bodies. Magnified image, the contact surface between the two bodies. If I am applying a horizontal force, the body tries to move, isn't it? The body tries to move. But here the frictional force is acting, which has to resist motion, isn't it? Here the contact happens. Why the block is in contact means here a total weight is acting. The weight of the block is acting. So, but this block is supported by the lower block. So, one support reaction will be created equal to the weight of the block, isn't it? So, this is a weight, one support reaction, normal reaction is acting. After that, I am applying a horizontal force towards left. So, here something has to resist this horizontal motion, that is friction. Okay, this F. So if I am applying towards left horizontal force, the body tries to move towards left. At the same time, the frictional force acts between the contact surface, which is giving an opposing resistance force to stop the body. So this resistance force is known as friction. Then what is the value of this frictional force means, which is equal to mu into n, which depends upon the normal reaction, and mu, which is coefficient of friction between the contact surfaces. So we can calculate the amount of frictional force acting on it by using this, because it is dependent upon the normal reaction and multiplied by the value mu, we will get the frictional force. Here we have two types of friction. We have static friction and kinetic friction. Okay, static friction means the body is at rest. Frictional force acting on the body which is at rest. Rest means impending motion. Force is acting, but the body is not moving. It is just about to move. So that time is known as impending motion. At that situation, the force acting on it, frictional force acting on it, is static friction. Then kinetic friction means when the body is moving, the frictional force acts. The amount of frictional force acting on the surface is known as the kinetic friction. Fluid friction means if we are applying an oil between the two contact surfaces, the frictional coefficient will be reduced. Friction will be reduced. Such type of friction is known as fluid friction. Then source or dry friction. What is the reason behind for producing the dry friction means asperities between the contacting surfaces. Asperities, that is irregularities. So here contact surfaces will not be perfect. So when we have magnified image shows like that, this irregularities, roughness of the surface is a source, one of the source. And interaction at the atomic level, atoms of this two bodies which may try to interact with each other, try to stick on each other. This is also the source of friction. Then tribology, we can study the tribology which deals with friction, lubrication and wear and tear. 3 times. Okay, friction, tribology is a branch of engineering mechanics which deals with the study of friction, lubrication and wear and tear, etc. Okay, just we understand what is friction, the force which resists motion. Then we will understand coefficient of friction. So at impending motion, F will be, the frictional force acting on the surface will be mu into N. Okay, which depends on normal reaction. So mu into N. So that mu is the called coefficient of friction. So which is the ratio of F by N. Okay. Then for impending motion, impending relative motion, the coefficient of friction will be termed as mu s, static friction coefficient. For actual relative motion, if the block is moving relative to each other, then mu will be mu k, kinetic friction. Okay, mu k always less than mu s. Mu kinetic friction will be less than. So from the diagram we can understand. So here F applied force. Okay, then here frictional force. When applied force is 0, the frictional force will be 0. Okay, applied force means, so here is a block is there, he is resting on a horizontal surface, so I am applying a horizontal force. So when I am applying horizontal force, one frictional force will be acting. Then if the body is moving or not moving, we can find if the net force is net force. Net force means applied force minus frictional force. That is a net force. So if the net force is not 0, means the body will have a movement, isn't it? But if the net force is 0, then the body will not move. So here see this image, force of friction. So when the applied force is 0, the frictional force also 0. Then when applied force is increasing, the frictional force also increasing to a maximum level, that is mu s, kinetic friction coefficient. Okay. Then after that, mu s into n. Then after that, the body start moving. From this situation, the body start moving. So when the block is start moving, the kinetic friction coefficient will come into play. The static friction coefficient will be reduced, somewhat reduced from the static coefficient. Then the friction coefficient will be same, frictional force also same for all type of movement. Okay, so here we understand kinetic friction and static friction coefficient. So here kinetic friction always less than static friction coefficient. Okay. Then laws of dry friction and also coefficient of friction we will understand. Maximum static friction we understand that, right? Fm is equal to mu s into n. Mu s means the static friction coefficient. Kinetic friction mu k is equal to mu k n, isn't it? Then the maximum static frictional force and kinetic friction are proportional to the normal force. Okay, it depends on only the normal force and it depends upon the type of conditions of contact surfaces, the roughness of the contact surface and independent of contact area. So frictional force is not dependent on contact area, but it depends on normal force and also it depends upon the surface conditions. So here we have the values of static friction Okay, for dry surfaces, for metal on metal, metal to metal contact surfaces means the friction coefficient may be changing from 0.15 to 0.6. Metal and wood combination means 0.2 to 0.6. So here we have all the friction coefficient. So here friction coefficient always less than 1. Then let us understand few examples of live examples of friction. Okay, here 4 situations we have 1, 2, 3 and 4 images I am keeping. So here one block is placed on a horizontal surface. Okay, so here when weight is acting downwards, normal reaction acting upwards, friction force will be 0 because the body is not moving. Px, so P is applied. So external force is applied in the direction, downward direction. There is no horizontal force at all. So Px will be 0. Resistance, friction also 0. Then if I am applying P at an inclined direction, at an inclined means it has split into two components, horizontal component and vertical component. So here horizontal component is acting, right? So the block will be try to move. So as the horizontal force is there, friction force will be in the opposite direction. So here no motion happens. Okay. So in the second situation, horizontal force is acting. So the friction force will be in the opposite direction of the applied force. Here F is equal to Px. So frictional force will be equal to the horizontal component of the force, but it should be less than mu s in maximum friction force, mu s into n. So if it is reaching beyond the maximum friction force means start moving. Okay. Here normal force, what is normal force here? So here downward weight also there. So here vertical component of P also there. So normal force will be the sum of these two. So here Px will be less than F. Then see the third condition, which is impending motion. Impending means just moving, right? It is not moving, but it is at the moment of start moving. So here what happened means here also the friction F is equal to Px. F is maximum, Fm. Maximum friction force will be equal to the applied horizontal force. Then Fm will be equal to mu s into n. So here these are same. Then here also n is equal to the sum of W and Py. So here applied force will be equal to the maximum friction force. Then you look at the fourth situation. Here the block is moving. So applied force has a maximum value greater than the maximum friction value. Here what happened means the block is start moving. Friction force acting in the opposite direction. So here Fk will be acting. So here Px will be greater than Fm, maximum friction force, maximum Fm, mu s into n. So we will get a value now, right? So which is greater value. Then mu k, Fk, the amount of frictional force acting on the surface will be calculated by Fk. Okay, Fk is equal to mu k into n. That's all. So here we understand the 4 situations. So where the block is not moving, the force is applied in the vertical direction. So here is an inclined direction. It has horizontal and vertical component, but it is less than the maximum friction value. So here impending, at the time of impending motion, maximum friction force Fm will be acting, which is equal to the applied force. So here in the fourth condition, the block is moving. Here Px will be greater than the maximum friction force. Then let us understand friction coefficient in all the cases. So here friction coefficient will be, okay, angle of friction also. Angle of friction means pi s, okay, pi s. So here see this friction force reaction. If an inclined surface means the reaction will be acting in this direction, net reaction, right? So here reaction component we have 2. So here W is the weight action force, P is also the action force, applied force. So reaction means normal force is a reaction force, friction also a reaction component, okay. Friction also a reaction component. Friction also a reaction component. So totally reaction, friction F, right, friction force acting, then normal. So the resultant reaction will be R, which is the resultant of normal reaction and friction force. So angle between this resultant reaction and the normal is known as angle of friction pi. So pi. The pi value is lesser value than pi s. Pi s means maximum angle of friction, pi s, which is equal to Fm by n. Tan theta. So here itself you find tan theta means opposite side by adjacent side, Fm by n. So this pi s is the angle of friction, which is the angle between the resultant reaction and the normal reaction. Okay. For moving, which is equal to Fk by n. Then if the block is there which is in a plane which is inclined to certain distance, inclined to certain angle means the situation, 4 situations we can understand. Okay, here also the normal will be acting perpendicular to the surface. Friction force will be acting in the opposite direction of the action force. So if the block is try to start moving downwards, because weight is there, horizontal component, weight is acting then inclined to the plane. So the net horizontal force will be there. Due to that, the body block start moving. Okay, sense of moving. Which direction the block try to move, like that. If I am applying a force like that, all applied forces, friction force. If the block is moving upward means, friction force will be acting downwards. Here also moving upward, impending motion. But when the block is moving downward means the friction force will be acting in the opposite direction. Okay, friction force, it depends upon the applied force direction. Then let us understand one problem. Okay, only example of friction force. So here see this, a block of 300 Newton is resting on an inclined plane, and a horizontal, it is not horizontal, a force of 100 Newton which is acting along the plane is acting. So 100 Newton force is acting along the plane. Now here in the question, a 100 Newton force acting on the block of 300 Newton placed on an inclined plane. The coefficient of friction between the block and the plane, so mu s equal to 0.25 and mu k will be 0.2. Determine whether the block is in equilibrium and find the value of the friction force. So we have to find whether the block is moving or not moving. Okay. So here first of all we have to draw the free body diagram. Okay, free body diagram. So see this is a free body diagram. Free body diagram means we have to represent all the forces. Okay, here weight is acting, right? Weight is acting towards down, then 100 Newton force applied force, then normal reaction will be created. Normal reaction will be created in the opposite direction, opposite 90 degree to the supporting surface. Okay, normal reaction. So if I am assuming that the block is moving upwards because 100 Newton force is moving acting along the plane towards right. So I am assuming that F is acting towards left. Frictional force is acting towards left. Okay, here how many forces? 1, 2, 3 and force. Then we have to resolve these forces into two axes. So here we have to take x-axis as along the plane. Along the plane we assume it as x-axis, and perpendicular to the plane take it as y-axis. So here 100 Newton is along the x-axis, along the plane. N is acting perpendicular, F is acting along the plane, but this 300 Newton force is a weight which is acting at an angle with the x and y axis. So here we have to resolve this 300 Newton force into two components. One should be along the plane, one should be perpendicular to the plane. So two components. Okay, totally we have 1, 2, 3, 4 and 5. So here we have to split 300 Newton force into two, along the plane and perpendicular to the plane. Then let us find sigma Fx and sigma Fy. That means sum of all horizontal forces and sum of all vertical forces. So here sum of all horizontal forces means this 100 Newton, right, towards right. So I put plus. Then this friction force will be in minus. Then the horizontal component of 300 Newton force, right? 300 Newton. 300 Newton means, so here horizontal components means 3 by 5, right? 3 is a horizontal component. 3 by the hypotenuse 5. So 3 by 5 into the value 300. Okay, 300. So we will get a value of F is equal to minus 80. Minus 80 means towards left it is acting. Then let us find sigma Fy, sum of all vertical forces. Sum of all vertical forces means here towards up normal is acting, right? So plus. Then this vertical component of the weight. Vertical component means here 4. Okay, 4 by 5. 4 by 5 of the 300 Newton force. Then we will get N is equal to 240 Newton. Then we can find the maximum friction force acting on the surface. Maximum friction force is equal to mu s into N. So here we find N. Okay, we find N value. So we are substitute the maximum friction force, which is equal to 0.25 into the normal reaction. So we get 60 Newton. Okay, 60 Newton. So here we find the maximum friction force as 60 Newton. But here the net resultant force is minus 80 towards downwards. Negative sign is there. So this is the maximum, the horizontal force, net force is more value. Okay, more than the friction value. Then what happens? The block is moving down the plane. The block is moving down the plane because the maximum net force on the downward direction is more than the maximum friction force. Therefore, the block is sliding down the plane. Then, if the block is sliding down the plane, we have to find kinetic friction. Amount of force, friction force will be not the 60. So as the block is moving downwards, we have to find the kinetic friction. F actual force, Fk is equal to mu k into N. So mu k is 0.2. It is given the question. Multiply by Newton. For 240 Newton, we will get actual friction force as 45 Newton because the block is moving down the plane.